Welcome back. In this video, we'll be overclocking the AMD Ryzen 9 5900X to 4.75 GHz using custom loop water cooling. We'll dig into 4 different overclocking strategies. First, precision boost overdrive. Second, we'll push the CPU to its maximum Prime 95 with AVX stable configuration. Thirdly, we'll push the CPU to our all-core maximum stable configuration. And lastly, we'll do some DOS overclocking. But first, let's look at the specific hardware we're using for this guide. The AMD Ryzen 9 5900X Asus ROG Crosshair 8 Dark Hero motherboard, an ROG Strix RTX 2080 Ti, G-Skill Trident-Z Royal DDR4 3200 memories, EK water cooling, favorite open bench table. Before we get started, let's look at some of the constraints that we'll be facing. A Ryzen 5000 CPU consists of a couple of parts, multiple chiplets, die with specific functions, fabric interconnect. The Ryzen 9 5900X has 2 CCDs with 1 CCX. The CCX has 6 out of the 8 cores enabled. The fabric, memory controller, and memory frequency operate in synchronous mode, all frequencies in a 1-to-1 ratio. In asynchronous mode, you will have a performance penalty. Let's jump into the benchmarks. Here's a list of benchmarks used in this guide. Let's take a look at the scoring at stock settings. As a first step, enable precision boost overdrive. We reran the benchmarks and check the performance increase compared to default operation. Let's start manually overclocking. In addition to overclocking the CPU frequency to 4.55 GHz, we also overclock the fabric and memory controller to 1.8 GHz. We also manually increase the memory frequency to DDR4 3600 and set the memory timings. This is also the highest Prime 95 small FFT with AVX stable configuration. We reran the benchmarks and checked the performance increase compared to default operation. If we ignore Prime 95, we can further increase the CPU frequency to 4.75 GHz while maintaining the same fabric and memory clock frequency. We reran the benchmarks and checked the performance increase compared to default operation. DOS OC is short for Dynamic OC Switching. Dynamic OC switching allows us to dynamically switch between OC mode and PBO. The real-world implication is that you can now benefit frequencies offered by PBO that go well over your manual overclock. DOS OC requires very little additional configuration work. We'll show you the configuration for maximum all-core manual overclock. Upon entering the BIOS, navigate to the Extreme Tweaker menu. Set AI Overclock Tuner to manual. Set memory frequency to DDR4 3600. Set F-clock frequency to 1800 MHz. Enter the CPU core ratio per CCX submenu. Set core VID to 1.4. Set CCD0 CCX0 ratio to 47.50. Set CCD1 CCX0 ratio to 47.50. Enable Dynamic OC Switcher. Set current threshold to switch to OC mode to 35 amps. Leave the CPU core ratio per CCX submenu. Enter the Precision Boost Overdrive submenu. Enable Precision Boost Overdrive. Leave the Precision Boost Overdrive submenu. Enter the DRAM timings control submenu. Set DRAM timings to 16, 16, 16, 16, 36. Leave the DRAM timing control submenu. Set DRAM voltage to 1.4 volts. Then save and exit the BIOS. Before we get to the performance comparison, I want to have a quick word on the current threshold value. The key thing to keep in mind is anything above the current threshold will force OC mode. Anything below the current threshold will force PBO mode. One way of identifying the right trigger point is to check the CPU current during a benchmark workload. First, make sure the system is set to default settings with Precision Boost Overdrive enabled. Then go into the operating system and load Hardware Info and Prime 95 without AVX. Gradually increase the amount of Prime 95 threads until you see the operating frequency drop below your desired manual overclock. When this happens, check the CPU current in Hardware Info, and this is the value you can use to configure DOS OC. We reran the benchmarks and checked the performance increase compared to default operation. We can see that with DOS OC enabled, we're able to squeeze a little bit more performance. Alright, let's wrap this up. Quite a compelling product for enthusiasts. On the overclocking side, there's not really that much difference. If you're tuning for a worst case scenario like Prime 95 with AVX, then you're going to be losing a lot of single-threaded performance. The biggest thumbs up goes to the DOS OC to benefit from the really aggressive PBO frequencies while also benefiting from the hard work that you put into manual tuning. Alright, that's it for this video. Till the next time.